Welcome everyone who is joining or has joined. Hope you're nice, safe, and healthy. Josh, how are you?
Doing all right. How are you, Gleb?
I'm excellent. Well, thank you for being a guest. And actually, Josh, you're not a guest, you're a host, right? This webinar is your webinar. With me is Josh Justice from Big Nerd Ranch. He is a web platform lead, and he has been at the company 5 years exactly. So, Josh, you want to tell us about what you do and what do you like about Big Nerd Ranch?
Sure. Yeah. I've been a software developer for about 15 years now. It's most of the time has been on the web. And so at Big Nerd, we do software development for companies. We will start new products from scratch, or we'll have developers join existing teams to kind of work with them and build and teach, kind of mentor. We work on the web. We also work on native iOS and Android platforms. We also do teaching as a company. So we do week-long boot camps to get you up to speed on any of these platforms and these published Big Nerd Ranch guides that are books. So when I'm dabbling in iOS or Android, I'll pick up one of those guides to kind of dig in there. I work as web platform lead. So that means in addition to being on a client project most of the time, I get to work with our internal teams to think about where to take our web focus and how to help our web team kind of level up in their engineering skills. And I really enjoy it. It's a place that's really challenged me, gotten me to think, gotten me to just grow as an engineer. So I'm having a lot of fun there.
Well, I'm really happy to hear this, right? Finding a job that you love and enjoy doing for so long is a great, great thing. And I assume you write a lot of Cypress tests, at least occasionally.
Oh yeah, whenever I have the option, it's the client project that I've started back in February was my first greenfield project that me and the team got our choice of platforms, and we've had full Cypress coverage from the very start. And so we just shipped our product nationwide just a few days ago. It was last Monday, and all the time our Cypress tests are catching things that are broken as we're enhancing the product. They've been absolutely essential to us building out this product quickly. It's been really great.
It's very nice to hear. So we have almost 200 viewers right now. This webinar will be sent to everyone who has registered by email probably tomorrow. We also have the slides. The slides are already public. They're available at cypress.slides.com. And if you want to ask Josh a question based on this webinar, you have to go to Slido, which is a URL, sli.do, and enter event code. And for this webinar, because it's called Using Code Smells to Fix Flaky Cypress Test, we picked event code smells. And as always, I'm your host for the webinar. I'm Gleb Bahmutov from Cypress.io. Now, Josh, if people want to follow you or ask you questions after the webinar, they probably should do it through Twitter. I know you're pretty active on Twitter. Right?
Yes, Twitter would be a great platform. I will definitely see it very quickly. I'm coding it wrong on Twitter. And as I always say, after the presentation, you can decide if I am, in fact, coding it wrong. If you'd rather reach me by email, I'm jjustice@bignerdranch.com. I'll be happy to chat with you there. I am a testing nerd. So anything in here, other ideas, conflicting views from mine, would love to hear from you.
So why don't we start with a little poll of our users? And Josh, can you go to the next slide, please?
Sure can.
If you go to Slido and you enter event code smells, we just want to know what's the web framework that you are using, or several frameworks that you're using. So you can go to the live poll and enter a single check mark or several check marks. And Josh, do you want to maybe pick the one that you code in so that we'll see results?
Sure.
Excellent. So I think this is what you kind of thought we would see, right?
Yeah, React obviously very high adoption across the industry, but with Cypress being such a wide-ranging tool, it's no surprise that we have a variety of different front-end frameworks represented here, and we're glad that all of you all across the whole spectrum are here.
Right. And even for people who don't code in React normally, I think your examples are pretty straightforward so that you'll be able to follow along and get something useful out of this webinar.
Absolutely. Yeah, the principles here apply to any front-end web application. And the examples are in React, but they're very simple ones. And I'll do my best to make it clear as we go. If I haven't done that, please ask a question, and I'd be happy to clarify at the end to make sure I'm explaining things well for anyone, regardless of what framework you work in.
Really appreciate it. So we got the sense of what the viewers code in. And if you're already at Slido, why don't you go to Q&A, ask a question, or upvote someone else's question that you want us to answer at the end of a webinar. So why don't we go to the next slide, if possible?
Yes.
OK, so let me just introduce really quickly this webinar, how it kind of came about. Josh wrote last month an excellent blog post identifying code smells in Cypress. I've read the webinar, read the blog post, and it talked about the free code smells, and Josh can kind of talk about the code smells. But if you take something from this webinar, go read this blog post later, because it goes into details of everything that Josh is about to show. Also, this blog post includes the repository URL at GitHub Coding It Wrong, Cypress Code Smells, where you can see React and Vue tests and code examples for this content. So today we're going to cover those free code smells, Unprepared Element, Flickering Element, and Impatient Test. And at the end, we'll answer your questions. So Josh, are you ready to show us how to find the code smells and fix them?
Yeah, let's do it.
Let's do it.
All right. So thanks again, everyone, for joining. I'm really glad you're spending this time, and I hope this will be helpful information. I think when it comes to testing front-end applications, two things are true at once. Number one, Cypress has made it easier to test modern front-end web apps, a lot easier. But number two, it's still hard to test modern front-end web apps. There's challenges, and a lot of the challenges come down to asynchrony. You've got different data loading and coming back in different orders, animations, users clicking around, clicking things you didn't expect that they'd be clicking at different times. So who knows what is going on in your app at any point in time. So when you have this kind of asynchrony in your applications, this asynchrony tends to lead to flake, and flake leads to suffering. I think of any of us who have used any kind of front-end testing for a long amount of time have experienced this. So what can we do about this flake? And by flake in this context, I mean it broadly to mean any kind of test failure that's unpredictable. Maybe it sometimes passes and sometimes fails in the same machine. Maybe it passes locally and it fails on the CI server, or maybe it's only some of the time that it passes on the CI server and sometimes fails. Anything where there's an unpredictable behavior to the test, it can really slow things down and make it painful. So we want to say, what can we do about this flake in tests? And really the solution is very simple. Just drop in sci.wait. You just put that in there to slow things down. Just all the way through your test, everywhere you can, sci.wait, 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 and it'll be fine. Your test suites will be great. Well, no, that is not the case. I don't imagine Gleb would let me go more than a second saying that. You do not want to sci.wait all through your test suite. And here's several of the reasons why. First, it makes your suite too slow. If you're getting the kind of extensive coverage you probably are going to want from your Cypress test, if you're waiting a second, 2 seconds all the time, it's just going to be an unmanageable slowness to the suite. Two, your tests are still flaky. You can wait long enough to get the test to pass on your local machine, but somebody else's machine, that wait may not be long enough. And so they're going to flake out again in the future. And third, I would argue that if you have to use sci.wait in your test frequently, it's masking real application bugs and things that if you can fix those in the application, you'll have a better experience for your users. And for that point in particular, we're going to see some examples of that as we go through the presentation. So if sci.wait is not the answer for these flaky tests, what can you do? Well, if you're a testing nerd, like me, I love this stuff. I nerd out on testing totally. You can probably eventually figure it out. Like I feel like I struggle with it, but if I think long enough, if I dig long enough into what's failing in the application, I can probably eventually figure it out. And probably a number of y'all here would consider yourselves testing nerds as well. I'm sure you could pull that off. But probably others here would not consider yourselves testing nerds. And probably not everybody on your project team is a testing nerd. We need people that are specialized, nerds about design or nerds about business requirements or nerds about database optimization. We need all those people on our software development projects. So what about the folks that aren't testing nerds, that don't read about this in their spare time like I do? Like, what can everybody else do on the team to be able to write and maintain tests that work really well and aren't flaky? So I think the concept of code smells can help here. And so let's talk about what a code smell is. The term was coined in the book Refactoring by Martin Fowler. Actually, the term was coined in the chapter that it's in. Kent Beck was a contributor as well. This is an amazing book for many reasons, so I highly recommend picking it up. So in the chapter on code smells early in the book, here's a quote from it. We have learned to look for certain structures in the code that suggest, sometimes scream for, the possibility of refactoring. So a code smell, it's a pattern, it's a structure you might see in a test. And when you see it, you say, you know, I've seen this before, and there's really something that needs to be done here. Like it's suggesting to you, it's pointing you towards, I think there's an improvement that's needed here.
Right.
So the way code smells can help here with our test flake is, and just in general, the way code smells help, is they can help you identify a problem pattern more easily because you've been given a name, you've had the concept drawn out and kind of focused on so you could see it more easily in the future. Code smells will suggest a solution to the problem to give you an idea of how to tackle it when it's not obvious. Code smells also ease communication about the pattern because now there's a name, you can refer to it. If someone hasn't heard of it, you could point to resources to learn about this code smell and kind of build up this professional knowledge that you can draw on in a repeated way. Also, code smells can help you to level up your team. You'll hear me refer to this repeatedly. You know, I want to help my team grow and get better and level up. And I want to learn from them as well. And so if code smells help that communication, then that's really great. An important qualification about the term, though, it can sound like a bit of a judgmental term. A former coworker of mine once reviewed a pull request and said, this code seems a bit smelly. So that stung a little bit, that hurt a little bit. And I know he didn't mean anything negative from it, but the term can come across as judgmental. And so I just want everybody hearing this to know that I don't mean it judgmentally, and I don't think you should feel judged about your code in general. I mean, you are not your code. The idea of bringing up code smells here is just to look for ways that we could take the code that we've written and make it better to serve us and to serve our teams better. So just know that there's no sense of judgmentalism going on in the conversation today. We're going to look together at 3 examples of Cypress code smells. I've come across these on a project that I've been working on lately. It's a large public-facing React application. I think I mentioned it a moment ago right when we got started, but this client I've been working with, we just launched the application nationwide in the US at the start of last week, and it's been running great. And so as we've been building this large application with a team of 7 developers now, we've identified these patterns of things that have caused flake over time and repeated things that have sort of emerged as these repeated code smells. So I found 3 of them on this project. Just to repeat the qualification from earlier, you don't need to be a React developer to benefit from this. The patterns apply across front-end frameworks, and I'm going to explain the code samples we are seeing as best as I can so you can follow what's going on regardless of what front-end framework you use. So with that, let's jump into the 3 Cypress code smells. The first one is called Unprepared Element. So let's look at the symptom here. Unprepared element is when you have an element, a DOM element, that's present but doesn't behave the way it does in manual testing. There's a difference in how it behaves between the manual test and the Cypress test. So let's give this a try and see. So in the example repo here, I have a whole bunch of different examples. We're going to hit some of them in the presentation today. But for example 1, we have the simple counter here. As we load the page or load the route, you can see probably, hopefully on the video stream, a loading indicator as that data is being loaded up. And once it's loaded, I can click the increment button to increment the count. All very straightforward. You've probably seen examples like this before. So now let's take a look at the Cypress test code that we're running on this. So it's very straightforward. We're going to visit this example. We're going to click on the increment button, and we're going to confirm that the count goes up from the initial value of 10 that's loaded to 11. So let's give this a try and see how it runs. We're going to run our example here. Goes through and it fails.
Something went wrong.
Yeah. So we expected to find the content 11, but it never did. It shows as a 10. So this is surprising. You know, when we loaded up the app and tried it manually, we got the count of 10 and we click increment, it works just fine. But in the Cypress
and it works now, right? Like Josh, like it actually works if you click increment right now. Right?
Yes, let the test run. When I can interact with the app through the Cypress UI, I'm able to interact with it. And so why did it behave differently when the test ran? So let's dig in to see why this is. So the symptom is that an element is present but doesn't behave the way it does in manual testing. Oftentimes, the root cause is that the element is added to the DOM before the data is ready for it to be interacted with. So Cypress is able to interact with the element, but it's unprepared. It's not ready for Cypress to click on it or interact with it in some way. So let's see what's causing this unprepared element in the case of this example. This component, we have a bit of component state here. It's the count, just an integer value, as you might imagine. Now in this use effect here, we're running some code when the component is initially mounted. We're just using a set timeout here. This is kind of like a minimum example to reproduce the problem, but we're using a set timeout before we load the count value. It kind of simulates a web service request that you might load data from a server. So after just 100 milliseconds, we set the count value from the default of null to the initial value of null to the value of 10. So after 100 milliseconds, that is set. And down here, we have the rest of the component where we render out the content. We render out the loading message if the count is not yet loaded, or the count value when it's present. And then we have our increment button down here. So what's going on here is the timing factor here with this count being loaded. So when we're manually testing it, I can't get down here to interact and click with the button in 100 milliseconds. Maybe if I refresh the page with the keyboard and click on it, by the time I can get to the button, and probably most human users can get to the button, the data is prepared, it's ready to go. But Cypress is faster than that. As soon as Cypress sees the increment button, it is ready to click on it and it's going to move on it. And so Cypress is going to be clicking the increment button before the timeout is initially set. So the count value is not ready to be incremented at that point. The element is there, but it's unprepared. It's not ready for user interaction. So we could jump right into fixing this specific case, but let's talk about the code smell in general. I wanted to say that I would argue that this is actually an app bug. It's not just a test bug, it's a bug in the application. And here's why. So I am, a kind of a slow user. And as a lot of us developers, we tend to often be on fast computers, fast internet connections. But if you had a user who's very fast at using your app and they had a slow device or a slow connection, they could very well get to the point where they could click on that unprepared element. And then maybe nothing would happen. Maybe the app would blow up. And so this is something that users can run into, and you can get surprising errors and certainly not a good experience. So rather than just getting the test to pass, I want to think about what can we do to fix this app bug to make sure that this situation we can't run across. We don't get the option of interacting with these unprepared elements. And I think there's fairly straightforward ways to do that. So the solution to an unprepared element is don't render the element as interactable until it is prepared. Don't allow the interaction until the data is ready to support it. And in our case, one way we can do this is using the disabled state of the button. So let's take a look at that. So in example 2 here is very much the same with one minor difference. On our increment button here, we're checking the count. And if the count is null, then our data is not yet loaded, it's not yet ready. The disabled attribute on the button is true when the count is null. So this means we won't be able to click on the increment button. And I mean, you can click in that area with the mouse. There's nothing that Cypress, the app can do to prevent that. But Cypress, with its intelligence about what elements can be interacted with, Cypress will also see that this button is disabled and knows that it can't click on it until it becomes enabled instead. So let's take a look at the test here to see this running. Actually, I'll look at the test code first. Notice that the test code is no different. We're still just visiting the page, clicking the increment button, and checking the count. So let's run this and see. So now the test succeeds. And if we run it repeatedly, it's succeeding reliably for us. As we hover over the steps on the left-hand side, we can kind of trace through the sequence that Cypress goes to. We visit the page, and notice now you can see that the increment button is grayed out. It's disabled while the loading message is showing. So Cypress is able to get that button. It finds the button right away.
Still disabled, right?
Yes, exactly. And so I see, Gleb can maybe give details on the sequence here, but as Cypress is toggling between the before and after states, you can see in the bottom right, it's showing that at the point that we're ready to click, the increment button has become activated and the count is showing. So that shows that the increment button is only enabled once it's ready to be interacted with and once we're ready to increment the count. And then sure enough, the count goes up to 11 after that click happens.
Right, right. And because we observe with DOM, right, before and after command, when you click, like if you click on a click right now, right, you can see before and after snapshot. So after we clicked, we know the count has incremented. So we know that it actually works because disabled attribute was gone, but built-in click check passed and increment actually worked. So you can kind of inspect those states.
Yeah. All right, so let's go back to the slides here. So there's a few different ways to make an element not interactable so that the test can't proceed this way. You could not render the element at all. Maybe when you start to think about it, like that element doesn't even need to be on the screen until it's ready. You could render it with the disabled attribute if it's a form element like a button that can be disabled. You can also cover it with an overlay. In our application, this is a loading overlay is a common thing we're doing on a number of our different pages. And Cypress will note that the element is not clickable because it's behind another element, and it will wait until the overlay is removed for the test to be able to proceed and interact with that element. But these are all ways that we're not allowing Cypress or an end user, a human user, we're not allowing them to get to the element to interact with it until the data behind it is prepared. So again, to summarize, for an unprepared element, the solution is to don't render the element as interactable until it is prepared. A brief note that I want to make is that, these examples are intentionally very minimal, and we're just looking at everything happening in one component here. So as we see, why would you set a value behind a timeout? Why, like you would be able to tell that button could be rendered. It's not obvious how you could run into this in a real application. If you look into the example repo, you'll see broader examples that are using, in our case, the Redux data layer. And this is more like a large application where data is stored in a centralized place. And when you get this separation of the component and the data storage, it's easier to see how you can get into these situations where it's not clear what's going on. I'll just show a glance at one of these real quick in example 3 here, where our count value is coming from our data store. We're using the Redux use selector hook. And if you're not familiar with Redux, all you need to know is that this is pulling the data from a central data store. Then down here, we're dispatching an action to load the count from the server. We don't see the AJAX call or anything in there, so it's not obvious the timing issues that are happening. And for increment, we see dispatching an increment. So here, this is just a very simple user interface that's pulling data from a centralized data store. So when you're just looking at the component, the timing problem and the problem with the component, the element being interactable is not as obvious. But as you dig into the code in your larger production application, once you start to see the code smell patterns, similar fixes can apply. In the same way for a Redux code example, you can add the same condition on there to disable a button when a count is null, when the data is not prepared, and then you're good to go. I won't go into too much detail to any of these Redux examples, but just know if you want to dig into those are available in the sample code.
We talked about this, right, Josh? We can actually make this check explicit in our tests, right? Like if you go to the passing spec, one that you're showing right now. So right after you get the button, you can say should not be disabled, right? Not disabled.
Is this the right syntax for that?
I think so, yes. So if you save it and look at the Cypress, I think that makes it pretty clear about what's happening. And so it gets the button and it's not disabled. Boom, now you're clicking on it. I know this, we talked about this check is built in, it's implicit, so you don't have to do it. But just for the clarity of sake, it could be.
Yeah, and I'm very much in favor of making our tests as explanatory as possible. So I like that a lot. All right, so unprepared element is our first code smell. Let's take a look at the second one. Flickering element. If you've run into this particular error message in Cypress tests, you may already be able to guess where this one is going. The symptom of a flickering element is you get the error, sci.click failed because this element is detached from the DOM. But if you look to the right, the element is still visible on the page. So let's see this happen here. And you may be able to identify if you've run across this before. So an example.
Know it, right, Josh? Because you shake your fist and like you curse Cypress when you see that error.
Exactly. Like my application's working. It's not my problem.
Yeah.
So, and that's why we dig in here. So check out this example here. As I reload the page, you can see that we're just showing a loading indicator that hides the whole content of the component while the data is loading. And then everything pops in after that. And yet we get this little wait here in Cypress. And Cypress says this element is detached from the DOM, the increment button. And yet, as I look over to the right, I see the increment button. It's right there. Cypress even lets me click on it. So what's the problem? Like, what is this mysterious error message? And Cypress is giving some helpful information here about what can be caused. So let's dig in together. So the root cause of a flickering element like this is that the element is added to the DOM and then removed, and then a second similar element is added. So let's see how that can be happening in our case here. This is very fast, so you likely won't be able to see this in the video stream, but it's possible for a fraction of a second over here, you can see the component popping in and showing itself before the loading indicator shows up. I think the sidebar might even help us see that. I think it might even be so fast that Cypress doesn't show us there. But yeah, so the component shows and then is hidden right away. And so that increment button is there and available at first, but then disappears. And one way you can tell if this happens is watch the as the loading indicator is going here while Cypress is waiting for the opportunity to do what it needs to do. Cypress says it's already gotten the button, even though on the right-hand side, we see no button there. So this is the hint that the button showed and was removed, but Cypress was able to grab it quickly before it flickered away. And so now Cypress is trying to intelligently say, hey, I'm not sure you want me to click on this because this element is not present. A user could not click on a button that disappeared so quickly. So Cypress is trying to be helpful here, and it is helpful. So the root cause when there's an element flickering away here, this is caused often if you're not using vanilla JS, you're using a rich front-end framework, a modern front-end framework like React or Angular or Vue. This is caused by a feature of them that is really great, which is declarative rendering. In all of these frameworks, you set up your data, you say, here's the user interface that I want to see when the data is in a certain situation, and then it handles rendering and re-rendering for you. And almost all the time, that is great. But it can lead to flicker because there's something that's implicit, like it is automatically rendering things for you in a way that's going to cause an element to disappear and then reappear later. You didn't code it that way to do it explicitly, but it still happens. So it's a speed bump you can run into with all the benefits of declarative rendering. And this suggests, well, before I get to the solution, let's talk about why this is an app bug. You may not be able to see it, but on a slow device, the flicker could be visible. The user could see, oh, a screen is there, and then it disappears in a fraction of a second. It may not be visible at all to you. The browser may not even render it because of the speed that things are going at, but on a slower device, it might happen. And that's the kind of thing that even if it's subconscious, the user experience of the user is, it just feels, they feel uncomfortable with the app. It feels like it's doing things in a surprising way. It's not a nice, solid, stable user interaction. So if we can fix the flicker, that's going to be better than just trying to work around it.
Right.
So one possible solution you can use to get past this error is to pass the force true option to sci.click. So what force true is going to do is it's going to skip a number of those checks that Cypress makes to see if an element really is realistically able to be interacted with. This will skip the check that the element is still in the DOM. It'll actually skip those visibility checks from before, like if an element is covered by another element, like an overlay, for example, this force attribute will skip over that. And so it's going to say, hey, please click on the element and minimize the checks you're doing. And so this may work in a given application. I think in my example code here, it actually wouldn't work because the data is not ready at that point. But again, this may get the test passing, but it's not fixing the application bug that is the flicker. So if we can fix the flicker, that would be really great. And so a way that you can do that in general is rework the flow of the data so that the element no longer flickers. So how to do this can differ a lot depending on your application. So let's see in our sample code how we can go about that. This is example 5. So in here,
I really like how your examples are organized so everyone can find them easily.
Thank you, yeah. All right, so example 5, this is the broken state. So let's see this before we can get a sense of how we can fix it. So we have a loading state value that's going to show whether the load is in progress and our count value. And so when the component mounts, first we're going to set loading to true. It starts out as false, but now we're starting the loading operation. So we set it to true, and then we do the thing, which in our case is a set timeout, but would really generally be a request to a web service. And then once the web service returns, we set loading to false, and we populate the value. So whenever loading is true, we're just going to render out a loading message. But when it's not true, we're going to render out the real contents of our application. So this is a case where the way that React behaves is actually different than Vue.js is the other framework that I most often use, and Vue handles this a bit differently. But in React in particular, in this example, when we start out the loading state value as false, this use effect that runs is going to happen asynchronously. It's not going to block the first render. So the first time the component renders, it's going to render with loading false. And so the code is going to fall through to here, not render the loading message, and render the main bulk of the component to the screen. So that's how the button first appears on the screen. Then when asynchronously, when loading is set to true, the component is going to re-render. We're going to get the loading message to render in place of the full component. And that's when the button is going to disappear. So that's how the button is removed from the DOM. But Cypress has picked it up from that first render. It's removed from the DOM. Then Cypress says that it's gone. And then later, after the timeout, the element comes back. And that's when we get surprised that the element seems to be there. And yet Cypress is saying that it was removed from the DOM. So the timing issue where the loading starts as false here and then is set to true is an artifact of the way React handles this timing. But these timing issues can come up in any framework. So the solution for our trivial code here is to start the loading state to true. We know in our component that when we first mount, we're going to be loading this data right away. And so let's just set the loading value to true from the start. That way, the first time the component renders, we're going to get this loading message. We're not going to get the button to show up until after the loading is done and the data is ready and we should be good to go. So let's see an example with that data flow change to prevent this flickering element. We run through, it passes. I'm going to run it several different times just to make sure that it's not flaky. And yeah, it's looking nice and stable. And we can see here that when we visit the page, we are getting that loading message right away. As we go down to get here, it's only coming up after the data has come back. We've got our count as well as our active increment button. So there, when we click it, we're ready to go and increment to 11. So we've removed that fraction of a second situation where the component rendered before the loading message popped up. Again, in manual testing, you might never notice it, but Cypress does, and is helping to drive you to this point to get your app to be more stable and reduce this flicker that's not a great user experience regardless. So your situation might be very different. The example I have in Redux is kind of surprising. Like the idea of setting the loading state to true in a centralized data store may not be the right approach. So in a production application, something more complicated might be needed to make sure that all the state is in the right place to prevent this flicker. So this can be a challenging one to work through depending on your application. But if you can remove that flicker, that's going to be the best user experience as well as the best testing experience. So again, to review, flickering elements. The solution is to rework the flow of data so that the element no longer flickers.
Josh, I also want to mention that this is a race condition, right? The application is doing a bunch of things, and the test runner has no idea, and they kind of race. Who will be the first one to render the button? The invalid state, or Cypress will get it, right? Or maybe the application will load the right button, and then Cypress will get it. So you have to kind of understand how application is working, really, right, in this case. And as I said, it's a race condition. Cypress has to sync to the application UI and wait for application to be in a valid state before it grabs a button and clicks on it. But it's a tough one, right? It could be really, really fast, and you have to know the internals of application to do this.
Exactly, yeah. It is the thing that, for me, has driven me to dig more into the React lifecycle, to understand how it works, timing issues, to more deeply follow it. And it's challenging stuff, but you come to this point where it's like the need for that is apparent. Like, right. Most of the time declarative rendering just works and you don't have to think about it. But in cases like this, it's good. And digging into those internals is going to help lead you to a more robust application.
Right. And look at the command log, right? See, there is a snapshot that kind of shows application, but is not really showing what you're supposed to show, right? Just look at those screenshots or dump snapshots.
Right. Cypress tooling there is going to give you more introspection into what's happening in your application to help you to dig in and kind of visualize it.
Right. Okay, more race conditions.
Yeah. So let's talk about this. The third code smell here, impatient test. So the symptom for an impatient test is when a test fails without waiting for the condition that would cause it to succeed. It's not that the application isn't working. It's like, just give it a second, it'll get there, and then it'll be ready to proceed. So let's look at an example of an impatient test that's rushing ahead of the application. Example 9 here will show this. All right, so in here, let's actually, before we run the test, let's take a look at the application itself. So in example 9, we've got a bit of a different example here. We've got a very not appealing user interface representing a system where you're signed in. And there's a sign out button there where you can sign out. We have an increment button again, but now we have two counts, a guest count and a member count. So I'm signed in now, so I'm signed in as a member. So when I click increment, it's the member count that's going to go up. But if I click sign out, after a second, it's going to sign me out and say that I'm no longer signed in. Now, when I click increment, it's the guest count that's going to go up instead, because now I'm a guest in the application. So we want to test this to make sure that it works. In our test here, we're going to visit the page, we're going to sign out, and then we're going to click the increment button. And we're going to confirm that the guest count goes up to 1 and that the member count has not gone up. So let's run this test. You can probably guess it's going to fail because that's how my pattern is going on here. So let's see why. We're going to the page, we're clicking the sign out button, we're clicking increment, but in the end here, even though we're signed out, it's the member count that's increased to 1 rather than the guest count. So why is this? Let's use the Cypress tooling to trace through here to see. We click on sign out here, we get the increment button and we click it. But notice the state of the UI here, it still says that we're signed in. And so it makes sense that when we click the count here, at this moment in time, because we're signed in, it's the member count that's going to go up instead of the guest count. And so our check of the guest count is going to fail. So it is correct for the increment button to be interactable, and how it's behaving is correct. The test is just rushing ahead. We want to wait until the sign out operation completes before we get to check the member count and before we click on increment. And this, when you're reading the test, you might assume that that's what's happening. I'm clicking sign out here. I want to sign out and then proceed on. But Cypress doesn't know that you and I have that in our heads. It just knows I've clicked on this element and I'm ready to proceed. I'm ready to move on. So that test, in a very good way, is eagerly moving on. But we need to find a way so that the impatient test doesn't rush ahead, so it waits until we're ready for it to click on the increment button. So let's talk about how we can do this. The root cause of an impatient test is that the next element to interact with is already present, and Cypress doesn't know to wait. It is correct for the increment button to be there in the DOM and interactable. It's just that there's something happening behind the scenes that we want to wait on. So there's a few different solutions that we can take. And one solution that I found for my trivial example code here is that you can change the app code so that the test can proceed immediately. If you can have something that happens synchronously just to register that the user has started the sign out process, maybe the test can proceed right away and you're good to go. But maybe that won't work for your application code. So we won't look at that example. We'll just move on. Solution 2, we can kind of take a page from our previous example and we can prevent interaction with the element. So let's see an example of this happening briefly. We can actually set the, let me look at the application code here. We can have a state that says is signing out. We should track whether we're in the process of signing out. That starts when the sign up operation begins and set to false when it completes. And once again, we can set the button to disabled so we can't interact with it during the during the signing out process. So this can work. And so let's just see this to visualize it. So here our test succeeds, and you can probably see it for 1 second there. That the increment button is deactivated while the signing out process is happening. So this can prevent it. We're using the same, we're treating the button as an unprepared element and we're deactivating it when we don't want it to be interacted with. So that can work great, but maybe that's not the user experience you want from your app. Maybe you say, hey, it is valid to click on the increment button at any point in time. We don't want it to disable it and then re-enable it. We just want something different to happen in the test. So the third solution you can use is to check what I call a green light. I kind of hit on this image for it just to kind of be visual and kind of remind you of it. A green light is just something you look at to decide whether it's safe to proceed. And that's exactly what we want to happen in the test. We want the test to check to see, are you ready for me to click on the increment button yet or not? So there's a few different ways you can implement a green light. Option 1 is to check an element on the screen. So in our case, we could think about this when we have the sign out button here and the signed in message. And then once we click sign out, a different message shows up. It says signed out. It confirms that we're signed out. And so if we look in the component, we actually have a data sign property on that to identify it, the signed out message. And so in the test, we can treat that as a green light and say, after I click on the sign out button, check and see if the signed out message is visible and wait for it to be visible before we proceed. This is the green light that's going to let us know that it's safe to proceed. We can run this and see this happening. And we can even see the Cypress waiting at that step for 1 second as the operation is proceeding. We can see that it's just waiting there. Expected span to be visible. So before the sign out button is there and the signed out message is not present, our green light isn't there yet. And then once signed out appears, hey, we've got our green light. Now we're ready to get the increment button and click because now the application is in the state that we're expecting.
All right.
So that can be useful. The other kind of green light that you can look for is a network request. You can check a network response to see that if it's completed. So in this case here, we're using Cypress network stubbing, but we're actually not stubbing out the response. In our case here, we are just still doing a delete request to this URL. If your test is stubbing out the response, that works just as well. But regardless, either way, the idea is that we take this request and we give it a name, sign out. And so this way, after we click on the sign out button, we can wait for that request to respond, to complete. Because once it comes back, then we know from that network request responding that we're safe to proceed. And this, I'll just show this to you succeeding in the test as well before we wrap up. The way you'll see this in the sidebar is when that XHR request begins, the name sign out appears here. And then Cypress says, I'm waiting for sign out to complete. And so if we're looking at here, the before and after this request, we can see the app toggling between signed in and signed out state. And so that now when we get to the state of clicking on the increment button, we know we've already gotten the response we need to know that we're signed out and we're set to proceed in the test. So green lights can be very useful if you don't want to change the user experience in your app. There is a warning with green lights though. The danger of a green light is it doesn't protect you if you forget to check it. This is true in real life and true in your tests as well. And so the way this can happen is we can get our test working here, checking the green light of the network request or checking the green light of the signed out button. And so this test works great. But if you have other tests in the future that you or other team members are writing, everybody needs to know to check the same green light in their tests. And if you don't do it, you're going to run into the same race condition and the same problem. Now, Cypress custom commands can help with this. When you know, hey, signing out is an operation that takes a couple steps, including checking for a green light. And so you can create a custom Cypress command. And that way, when developers, including yourself, are following the existing patterns, you use that custom command. It's going to provide those checks that need to happen behind the scenes, and you're good to go. And signing out is an example where we've used that on our application to provide that extra safety to know that everything is synced up and is ready to proceed after the sign out happens. So just to summarize again, the impatient test code smell. When this happens, you can address it by enable the test to proceed immediately, if you can, or you can prevent interaction with the element so that the test doesn't have the option to proceed, or you can check a green light. So let's review. This has been kind of a fire hose of information probably with these different code smells. So let's just see them one more time to get them into our head before we go to Q&A so you can be thinking about questions that you have. So the three code smells we looked at are unprepared element, when an element exists but is not ready for us to interact with it. The way we can fix this code smell is to not render the element as interactable until it is prepared to be interacted with. 2, flickering element. When an element is flickering, causing an issue for the user and for the test, we can rework the flow of data so that the element no longer flickers. 3rd, for an impatient test, when the test is running ahead, you can update your code so that running ahead is just fine. You can prevent the interaction, like an unprepared element one more time, or you can check a green light to intentionally, explicitly slow the test down until it knows it's ready to proceed. So these are our Cypress code smells, at least the ones that I've found so far. The takeaways that I would encourage for y'all is, number 1, look for these code smells in your application and in your tests, and see if you've already solved them in similar ways, or if not, maybe try the solutions that are presented here and see if they're helpful for you. 2, I'd encourage you to share these code smells with your team. Maybe it helps someone get into test reliability and debugging that felt a little helpless before. Maybe it gives you all a common language to be able to talk about these things and help one another level up. And number 3, look for other code smells. These are just the 3 that I found on my application, but I think it's a useful concept, and I'm sure that y'all have found other code smells and patterns as well. Find those patterns, give them a name, send them to the Cypress folks, send them to me. We would all love to hear about this just so we can help one another level up and just build our professional knowledge as software testers and as Cypress users. I think this is a helpful concept. It's helped me, it's helped our team. And I hope this idea of looking for these patterns and giving terms to it will be helpful for y'all as well, as we're all trying to level up in our testing together.
We can definitely document this in our best practices guides, in our documentation side. These are very, very good code smells to look for. Unfortunately, they're a little bit more complex than just like define an ESLint so you can automatically, kind of catch them. But that's where, you as a developer, as an intelligent human being, can come in with experience and look for them.
Yeah, I like to say about testing in general that software testing is not something that can just be simplified down to just simple steps to take. Like there's nuance, and certainly that's the case with asynchronous testing as well.
All right. Right. So I have to add the following. Even your example with like logging out, I hit that problem. We hit it in our real world example app where we were signing out or logging out. And when we immediately try to like run assertion without waiting for the user to be logged out because it takes time. So I've been writing those blog posts and tagging them with tag flake. So if you go to Cypress blog, you can find a lot of blog posts talking about code smells, how to search for them, and what to look for, like suddenly changing URL or element has been detached and so on. So for additional information, as after you read Josh's blog post, definitely go there. Josh, thank you so much. Are you ready for some questions? Because we do have a lot of questions. If you go to the next slide.
Yeah, I'm ready. Let's go.
Do you see any question that really catches your eye and I can?
Yeah. Let me think through from the start here. What's the preferred way of test data generation to reduce testing time and make tests stable? I think when it's come down to test data generation, the problems that I've had with that haven't led to test flake like this per se. I guess in the sense of something, succeeding in one place and failing somewhere else. I've seen that happen when you're using like randomized test data. And so when you can lock down the test data instead and you say, okay, well, I want to hard code some test data, not because all the details of it matter, but because I'm just going to test the scenario where an example I gave in another talk is when you've got addresses, like mailing addresses. I'm going to have one test example that has a 2-line address and another example that has a 1-line address. And I'm going to test both instead of randomizing it so that I'm always covering both of those scenarios. And so I know in another Cypress webinar I saw recently, they talked about pulling down data from a remote server, and that could be helpful as well. But yeah, if you're generating test data that's non-deterministic in that way, leaning more towards like making it more deterministic, I think can prevent flake.
That's a great answer. So let me mark it as answered. Yeah. Can you actually talk about this? So a reusable custom command, for example, for logging out, waiting for green light to proceed. Do you create a lot of custom commands? Do you create page objects? Like, what's your view on this?
Yeah, we just had a Cypress person get on the phone with my client team yesterday and talk through this with us. And when I was talking to her, we described this in this commercial application that I've been describing and working on. I've seen page object models that are just very abstracted and hard to follow, especially as a new developer coming into a big, large code base. And so as we decided to say, hey, let's start at very low level with tests that are directly interacting with DOM elements. And let's pull out custom commands only when the repetition is so much that it's painful for us to leave the repetition in there. And so we've started only pulled out the custom commands that are used all the time, very frequently, or the ones like the green light situation where it's going to be unsafe for somebody to log out unless they do these 3 other steps to check to make sure that things are there. So on our application so far, we've only made very small steps towards creating custom commands. But I'm curious, Gleb, if you have other thoughts of other ways to think about how or when to do reusability.
I had a whole presentation about this, and I placed the slide URL into the chat. In my opinion, creating a few reusable functions or custom commands like you talked about for signing out safely is fine. People usually try to do page objects to interact with everything on the page, right? Like you don't interact with a page directly. You don't use side commands. You always go for page object. And I think it's huge overkill and it's not necessary, right? That's my opinion. So maybe a quick question. Do you consider SciWait for SciRoute alias just as bad as a wait, or do you like it? I think you actually showed this is a good solution, good green light, waiting for a network request.
Yeah, and actually, this question makes me realize that my slides were not clear, so I apologize for that. When I was recommending against sci.wait, specifically what I meant is waiting a certain number of milliseconds. Going in and saying, well, just wait this amount of time, and by then probably everything should be fine. That approach is flaky because it's arbitrary. You may not be always waiting long enough, and oftentimes you're going to be waiting too long and slowing down your test suite runs.
Absolutely.
So using SciWait to wait for a network request doesn't have any of those problems because as soon as that network request comes back, the real one or the stubbed one, your Cypress will proceed right away. And so it's not going to be waiting too long, not going to be too short. It's not going to be flaky because Cypress knows, it introspects and sees when that request came back. Right. So I will, Gleb, if it's even possible for me to clarify that in the slides before we publish them, I think that would be great, because I don't want to mislead people there. I think side.wait for a network request is very much a plus. I will, redirect back to, thinking about how to solve an impatient test. There are different trade-offs. If you can, there's two different ways to do a green light. You can check a network request or check a UI element. And there's trade-offs there on which detail you're coupling to. You're looking for something specific in the UI or looking for a network request. And either of those could change in the future. So you can pick one or the other of those to wait on. Or if you can change your application so you don't need to check a green light, there's benefits there as well. So those are all great options. It's really only waiting for a certain number of milliseconds that I'd strongly recommend against.
Do not hard code waiting for 30 seconds everywhere, right? Do not. I just want to add a warning, right? When you wait for a network request, I personally don't like doing that for two reasons. You time yourself a little bit to implementation, right? You don't know like what call will be. Maybe you'll change it and you'll have to change the signature. But it might be okay, right? If you have a reusable function that you call all the time, so you will change implementation in one place. But another thing is that your application might have extra logic. So after the network call completes, it might take a while for UI to update. And so if you're waiting only for the network call to complete, you might get into impatient and flickering element code smell. So I usually prefer waiting for something obvious on the page, right? An element appearing or disappearing or text appearing. So, use your judgment here. Josh, here's a good question, right? Which was upvoted. Do you have any suggestions for what documentation to read if you want to up your Cypress game or test writing game in general?
Yeah, it's going to sound like I'm pandering, but I really think the Cypress documentation is really, really great. One of the reasons why I think that is because it doesn't just teach the technology; it has recommendations on how to think about those things. And let me give an example there. So my encouragement is to read through the Cypress documentation, not just for how to get things working, but for the recommendations as well. So when it comes to network request stubbing, let's see here. Yeah, what approach do you want to take? Do you want to use real server responses? And this gives benefits and downsides and suggested use. Or do you want to stub responses? And here's the benefits and downsides and suggested use. And so there's examples of kind of pulling from both to use the best of both worlds. When I'm on mobile testing and when I'm thinking about other types of testing, I point people to this documentation because I think this testing principle here is really, really great. And so definitely read through the Cypress docs. There's one more resource I point to a lot called XUnit Test Patterns. It's a classic testing book. I've given a test on it before, a talk on it before. It's a bit more, as you can tell from the name, it's a bit more focused towards unit testing, but it's cross-platform, it's cross-framework, and it has these really great test patterns and test code smells in it that apply to Cypress tests as well. For example, when we were talking about the test data and how to avoid flake there's patterns in this book that address that directly. So I think you will benefit from knowledge across platforms and across the decades by reading this book. It's a really great one.
Thank you. I definitely recommend looking at our documentation, searching, because we have pretty good search, but we'll find both documentation, recipes, maybe kitchen sink examples. Josh, do you want to answer any particular other question? And you can scroll through questions as well, I believe.
Sure. Let me just start at the top. I think these are all great questions, so I'll just kind of start at the top of the top votes. Wouldn't it make the test more robust to check response status to be 200 before proceeding with the rest of the assertions? I think that could definitely be beneficial. It's partly the example of just the fully reduced examples that I've been showing here. But yes, if you want to see that the response came back as expected, certainly if you're hitting a real server in your test, checking that response could be good. But to Gleb's point, you also might just check what's showing up in the user interface, and that something in the UI that's representing success would be good as well. Like, there's a good general testing principle here that relates to how many details you're coupling to. When you keep your tests very light and just have like the minimum elements to interact with to move through the app to get to the state you want to be in, that allows things to change under the hood. But also you can get into a situation where there's something you didn't check, like, oh, the status was not 200 and I didn't expect that. And then you don't find out until later in the test run that something's gone wrong. And so I think that's a judgment call that you make, is when you find in your application that adding certain checks is going to get you helpful data earlier, kind of similar to what Gleb was saying around like explicitly checking that an element is not disabled. This is another explicit check of a response status. So I think adding those details when they benefit you, but not feeling like you have to add them all the time because it could clutter up your tests and make it harder to follow. So I think it's just an it depends situation.
Yes, and I would say take a principle of you're not going to need it, right? If you never hit a problem, right, with signing out, well, why check for response status 200 in every test, right? But if occasionally you hit this problem and UI shows it, well, the test will probably fail, and you'll have a screenshot and a video, and you'll see, oh, wait, my logging out can fail. So maybe in my test, I will check for that, since I see that there is a need. But if you're not going to need it, maybe not.
All right, the next question asks about design patterns like in a certain blog post to avoid code smells for Cypress. The dog is excellent, so it's already got my attention. I have not read this post, and so I'm skimming through. I see they talk about page object model. And so, yeah, I think I would honestly, I'd probably need to process through this post to be able to recommend. I see that they're drawing on some kind of general software design principles like the facade pattern, the factory pattern there. And so I love these patterns in general. And so thinking about them, but when it comes to any software design patterns, I mean, kind of just like what Gleb just said, you don't want to engineer your application, over-engineer your application code, and you don't want to over-engineer your test code either. And so I think knowing about patterns like this, if you're someone that likes to read about these things, knowing what tools you have at your disposal and knowing the pros and cons, that can let you think about it. And when you do try out a new approach, if you can try it in an isolated project or an isolated part of your project and see how it works. I'm a big just proponent of, every developer is different, every team is different, every project is different. And so, see the benefits you're getting from a certain approach to software, or see the costs. And then that way you can see if you want to perpetuate it or take it back out.
Thank you, Josh. Well, I think this is a great last kind of question answer because we're out of time. If you don't mind, Josh, can you go to the next slide? I want to show the URL again. I want to thank you, Josh, for preparing all the material here. It's all you. You wrote an excellent blog post. That's why we invite you. And I want to thank our viewers, right, who were with us, learning something. The slides are online, and Josh, you're welcome to edit them at any time, right, to clarify, side that weight. The blog post URL is here, and the GitHub repo is also right here. Josh, any parting thoughts?
Yeah, just thank you so much, everyone, for the interest. Thank you, Gleb and the Cypress team, for giving me a chance to speak with y'all. I love to partner up with y'all with this great tool that you have. And yeah, if this stuff gets y'all excited, just dig into testing. There's always more to learn. There's always more to make the experience better, to help your app, to help your teammates, to help you to go home and not have to work nights and weekends with stuff that's airing out. I mean, quality of life for developers and delivering great products to companies is what I care about. And I think testing and I think Cypress help with both of those.
Thank you, Josh. Really appreciate kind words. Well, that was our Cypress webinar. Thank you very much. Stay healthy. Happy testing.
Thanks, everyone.